morning, dear students. So, last class we were doing regarding chemical equations from chapter Language of Chemistry, chemical equations. So, what is a chemical equation? Chemical equation is a such representation of a chemical reaction. Short representation or symbolic representation of a chemical reaction using symbols and formulae. So chemical equations again are of two types. One is a skeletal equation or unbalanced equation, and one is balanced equation. So regarding unbalanced or skeletal equation we had done in the previous class, in the last class. So in that, again, if we have to write a reaction of carbon and oxygen, reaction of carbon and oxygen, then we are supposed to write carbon plus oxygen gives carbon dioxide. Carbon dioxide. This becomes word equation because we are writing chemical reaction in which form? In the form of word. In the form of word. So this becomes word equation. Word equation. Now, if I write this in symbols, in formulae, then it becomes chemical equation. Now, last time we learned that how to write equation. So this arrow means on the left hand side of this arrow is reactant, and on the right hand side of the arrow is product. If there are more than one reactant, we put plus. If there are more than one product, we put plus in between the products or in between the reactants. Okay. Now, what is the symbol for carbon? It is C. And symbol for oxygen? It is O. But what we have learnt is we cannot write in atomic form. We cannot write in atomic form. Okay? We cannot write chemical equation in their atomic form. Whenever we write chemical equation, we have to do in which way? In the form of molecule. We have to write in the form of molecule. We have to write the molecule. Okay? We have to write the molecule. So molecule for oxygen is O2. Molecule for oxygen is O2. And then this C plus O2, we know we can write this carbon dioxide as CO2. CO2. This is skeletal equation. This is word equation. Word equation. And this is skeletal equation. Here, skeletal equation is balanced. Skeletal equation, one carbon, two oxygen, hence it is balanced. So no need to balance. That means some of the skeletal equation are balanced equations. Some of the skeletal equation are balanced equation, and some of the skeletal equation, most of the skeletal equations are unbalanced. For example, if we have to write the reaction between hydrogen and chlorine, hydrogen plus chlorine gives hydrogen chloride. hydrogen chloride. Hydrogen symbol is H, but we cannot write in atomic form. We have to write in molecular form. So molecule of hydrogen is H2 plus molecule of chlorine is Cl2, because these are diatomic molecules, diatomic elements. So hydrogen is diatomic element, chlorine is diatomic element. That means their molecule has 2 atoms. So whenever we are writing chemical equation, we have to express element in molecular form. So H2 plus Cl2 gives HCl. Last time in the skeletal equation I wrote this. Now when we start counting the number of atoms on the reactant side and product side, then let's see here hydrogen is 2 and hydrogen is 1 here. Chlorine is 2 and chlorine is 1 here. So this is not balanced. This is not balanced. So this is a skeletal equation. Skeletal equation. And this also can be said as unbalanced equation. Unbalanced equation. This is unbalanced because this is not balanced. Number of atoms of each element on both the sides are not equal. So this is unbalanced. But here skeletal equation itself is balanced. That means what is the skeletal equation? The skeletal equation is the direct representation of chemical reaction in symbolic form. Direct representation of chemical reaction in symbolic form becomes skeletal equation, and some of the skeletal equations are balanced. You don't have to balance it. Some of the skeletal equations are unbalanced. You need to balance it. Now, need for balancing a chemical equation. Why do we have to balance a chemical equation? Why we need to balance a chemical equation? Why? In order to follow law of conservation of mass. So what does law of conservation of mass says? It says that mass is neither created nor destroyed in a chemical reaction. That means in a chemical reaction, atoms are not created or not destroyed. Here 2 atoms of hydrogen are there, but here we can see only 1 hydrogen. That means what can we see here? One of the hydrogen atom is lost. It is destroyed. One of the hydrogen atom is destroyed. That's why we are getting only 1. One of the chlorine atom is destroyed. That's why we are getting 1 chlorine. So this does not. That means if we write like this, it will not follow law of conservation of mass. Means there is shortage of mass. There is shortage of mass. For example, one hydrogen atom, mass of one hydrogen atom is 1 AMU, and mass of 2 hydrogen atom is 2 AMU. And mass of 1 chlorine atom is 35.5 AMU. Last time I said you to learn all this also. So 2 atoms makes 71 AMU. That means how much of reactants is there? 73 AMU. But if you calculate here, it comes around 1 and plus 35, so we will be getting 36.5 AMU only. So a lot of mass is lost. And what does law of conservation of mass says? Mass is neither created nor destroyed. It should not get lost. So in order to follow law of conservation of mass, in order to follow that the mass is not lost in a chemical reaction, we need to balance a chemical equation. So what is the need for balancing a chemical equation? We need to balance chemical equation in order to follow law of conservation of mass. Means in order to follow that in a chemical reaction, no mass is created or no mass is destroyed. That means I cannot write here 3 also. I cannot write, because again what we can see is mass is created. And if I write this much only, then what is understood? Mass is destroyed. In the reaction, mass is destroyed. That's why we are getting less mass. So, in order to follow law of conservation of mass, which states that mass can neither be created nor destroyed, we have to balance a chemical equation. So, we have to balance a chemical equation. Now, what is a balanced chemical reaction then? What is a balanced chemical reaction? A chemical reaction in which number of atoms of each element on the reactant side is equal to number of atoms of each element on the product side. That means, what is a balanced chemical reaction? Balanced chemical reaction. Balanced chemical reaction. So what is a balanced chemical reaction? In which number of atoms of each element on the reactant side is equal to number of atoms of each element on the product side. On the product side. So, this is a balanced chemical reaction. So, which reaction we can say a balanced chemical reaction, or reaction in which number of atoms of each element on the reactant side is equal to number of atoms of each element on the product side. That means is this a balanced chemical reaction? Is this a balanced chemical reaction or balanced chemical equation? Is this a balanced chemical equation? Yes? No. Because number of atoms of each element on the reactant side, here hydrogen, number of hydrogen atom is 2 and number of chlorine atom is also 2. On reactant side or left hand side. And in right hand side, number of hydrogen atom is 1 and number of chlorine is also 1. So it is not balanced. That means this is not a balance. That means this is not a balanced chemical reaction. This is not a balanced chemical reaction. Now, in order to follow law of conservation of mass, so by naturally, but whenever we write the direct symbols and formulae only, it will not be balanced. That means we need to balance this equation. We need to balance this equation. Now, that I think you understood now what is the need for balancing a chemical equation and what type of equation we can say a balanced chemical equation. So we'll learn now how to balance a chemical equation. How to balance a chemical equation. How to balance chemical equation. How to balance a chemical equation. Okay. Mind you, whatever steps I am going to write, that is not there in your book. So make sure that you copy in your copy. Number 1, step number 1. Steps. Number 1. Balance metal first. First you will balance metal. Number 2, balance non-metal other than hydrogen and oxygen. So first of all, you see in a chemical equation, which are the metals? Then first of all you balance metals. Then you balance non-metals other than hydrogen and oxygen. Balance metals, then balance non-metals other than hydrogen and oxygen in the chemical equation. Then number 3 you can balance oxygen. Can balance oxygen. Number 4 you can balance hydrogen. So finally you can balance hydrogen. So first of all balance metals, then balance non-metals other than hydrogen and oxygen, then balance oxygen, then balance hydrogen. So this is the step we will be following for balancing a chemical equation. Okay. Then we'll start with example. So for example, the same reaction we'll be taking. H2 plus Cl2 gives HCl. Okay. Now here hydrogen is 2, chlorine is 2, here hydrogen is 1, chlorine is 1. That means this is unbalanced equation. This is unbalanced equation. Now how to balance this? First of all, balance metals. Here are no metals. Hydrogen is a non-metal, chlorine is also non-metal, so no metals. That means go to number 2. Balance non-metals other than hydrogen and oxygen. Other than hydrogen and oxygen there is chlorine. So balance chlorine first. Chlorine is 2 here and chlorine is 1 here. So make these 2 by adding number in front. You cannot add numbers here anyway. Always add number in front. So 2. That means chlorine is 2, chlorine is 2. Now hydrogen is 2, hydrogen is 2. So this is balanced. Okay. So step number 1, balance metals. There are no metals, so you went to step 2. Balance non-metals other than hydrogen and oxygen. So oxygen is not there. See hydrogen. So other than oxygen and hydrogen, what is here? Chlorine. So balance chlorine then. Chlorine 2 this side, chlorine 1 was there, so you added 2 in front. You cannot do like this. Okay? You cannot change molecular formula. Okay? So if you do like this, then molecular formula will get changed. You cannot change. You add number in front. Always add number in front. So chlorine 2. This 2 is for chlorine as well as for hydrogen now. So hydrogen, then comes balance oxygen. Oxygen is not there, so you will be balancing hydrogen. Hydrogen 2 and here also hydrogen is 2. So this way we will be balancing. Let's see other examples also. Now another example we will be taking, that is burning of magnesium. In the presence of oxygen. In the presence of oxygen.